Okay. Yeah, now it
Many
should be
thanks,
recording,
Andrea.
right? Okay. Yeah, sorry, forgot about that.
No worries.
Perfect. Yeah. So who am I? I'm Andrea. As you probably noticed from the accent, I'm Italian, but I live in the Netherlands. I live in Amsterdam. I've been freelancing as a consultant and trainer in the field of cloud technologies, mainly around Kubernetes, container, microservices. You can find other talk that I gave in the past, more in general about infrastructure, automation, and the don't repeat yourself principle. What are we going to do today? So we will start with a couple of slides before getting into the more hands-on lab, okay? So we will start with a brief introduction about GitOps and some base concept of GitOps, what it is, why it's needed, why it's important. In particular, we will talk about tools that are available to do GitOps in Kubernetes. In particular, we'll talk about ArgoCD. We will have a little demo where we will install ArgoCD, explain a couple of its main functionality, and we will see how we can organize our GitHub repository, deploy our first pipelines. I will give you a couple of suggestions and pipelines, suggestion and best practice based on my experience. And then, of course, we will have time definitely for some Q&A. Let's get started. So GitOps. GitOps is a word that came out from the folks over at WeWorks. You might know them because they're pretty famous in the open source community. And it's founded on 4 different principles. The first principle is that the entire system that you are running should be described in a way that is declarative, okay? What does it mean to have a declarative description of your infrastructure, a declarative description of your system? Programming language can be defined in a declarative way or non-declarative way. Something to say, for example, an example for a declarative way of defining things is I want to spin up 10 Redis server. Okay, so configuration in a declarative way is guaranteed by a set of facts. Instead, in a non-declarative way is done by a set of instructions. So rather spin up 10 Redis server and check the one that worked and the one that didn't. So rather than specifying a set of instructions inside our configuration manifest and so on, we specify a status. So we specify the final status of the system, what we would like to have in our infrastructure, in our Kubernetes cluster, in our cloud. The same way also works, for example, for tools like Terraform. In Terraform, we define a state of the system. We define as a code the state of the infrastructure we want to have, and Terraform takes the appropriate step to bring our cloud infrastructure to the state that we described as code. So the first principle of GitOps is the entire system needs to be described in a declarative way. Second principle of GitOps is in the word itself. The canonical desired states of the system is version and is version in Git, right? With GitOps, we would like to have a single place from which everything is derived and driven, meaning that we want a single place where we keep our configuration and manifest for the infrastructure, rather than having scattered across many different repos. We will see that in certain cases, this might actually be useful, but the idea is that we make it in a way that it makes sense, right? In a way where dependencies are clear, when it's clear the relationship between all the different parts of our infrastructure. Principle number 3 says that approved changes can be automatically applied to the system. This means that we should basically forget about kubectl apply-f in the same way when we went from running servers to Kubernetes, we told ourselves to forget about SSH. So the idea is that there is an agent, there is a software component that automatically applies changes to our system. So all the changes that we want to be applied are applied by an automated process rather than a user or a system administrator, for example. So no manual intervention in general should be required whenever we need to deploy a new change or to revert a change. Principle number 4, a software agent ensures the correctness and alerts on divergence. So we will see that we will have a software agent, in our case, ArgoCD, that makes sure that the software definition that we have in our pipeline and in our repository is the same that is running inside Kubernetes. And this software agent will also alert us in case soft configuration drifts are present in the system. And on top of that, it will also try to fix these configuration drifts in case they are detected. But yeah, let's go and let's see a little bit more about GitOps. Which tools are, the tools available for GitOps out there, specifically for Kubernetes? Well, the battle, I would say, is between these two, ArgoCD and FluxCD. Both of them are equally valid. Both of them are mature software that has been developed since, several years, I would say, at this point. My experience, I worked mainly with ArgoCD. I like it very much. So in this workshop, we will focus a little bit more on ArgoCD, but this doesn't mean that FluxCD is not a valid alternative. Actually, I know a lot of colleagues that are very happy with the way Flux works. But most of the principle around GitOps and the GitOps mentality are valid for both these alternatives. So, this is just a matter of tooling. It's not really important which tool that you use, but rather the principles that you apply while using them. This diagram explains a little bit how GitOps work and what is the idea behind GitOps. The idea is that, of course, at the center of the picture, we have our Kubernetes cluster. Our Kubernetes cluster is the one that is hosting our workload. It's running the API server. It's running all kinds of components that are running our applications. Then we have some incoming arrows. So these are the agents that are interacting with the system. And we can see our CI/CD, for example, down here. We can see our user accessing the Kubernetes service using a dashboard, for example, or a CLI. But all the changes that we do to our application, they go through Git. We can see up here that using pull request and webhook event, what we can do is actually deploy a new version of our application, or for example, even deploy a new application from scratch in different environment or in new clusters and new environment. What is also important to see down here is that with GitOps, with ArgoCD, but also with FluxCD, we have the possibility not only to deploy in the cluster where ArgoCD is deployed, but also in other cluster, as we can see here in the bottom right of the slide. And also, for example, send hooks and the application action. This means that if our application, for example, synced successfully, or if a new event has been created, a new version has been deployed, I can send a message to external system to alert them that something has changed. So I might set up a Slack notification. I might put a certain alert, I might trigger a certain event in my monitoring system, right? So this GitOps tooling, like ArgoCD and FluxCD, act in between the user and our external system. So they take the instruction from the user, from a Git repository. Remember that every configuration is defined as code. And then they have the possibility of triggering external actions, like deploying on the cluster or sending a notification to an external system. Let's talk about a couple of core concepts of ArgoCD, and then I promise that we will move to the actual practical part. These are a couple of names that ArgoCD use that if we don't know from the beginning, might get a little bit confusing later during the workshop. So the first name that I want you to learn about is tool. So ArgoCD defines as tool a software that is used to generate manifest. So Kubernetes manifest in this case. We are talking about Helm, Kustomize. You might be familiar with these two. They're quite popular. But of course, our software, our Kubernetes manifest might be even plain YAML. So every tool or every software that is used to generate Kubernetes manifest is called in the ArgoCD world a tool. From a tool, we get an application, right? So when I render my Helm chart, when I use Kustomize build, what these two tools are doing is taking a set of templates, a set of template file, and they're rendering them, right? And they are rendering a so-called application. An application in the ArgoCD world is nothing more than a group of Kubernetes resources. So a group of different deployments, services, config maps that are part of the same unit. So they're called an ArgoCD application. And this application that we have running in our cluster, we will see that in ArgoCD, it has two different possible states. The first state is the so-called live state. This is the state of the app. So this is the live state of the app. So what is actually deployed in the cluster? This is the live state of the application. The second state is the so-called target state. So is the desired state of the app, what should be deployed. So the target state is our declarative definition of what we want to be deployed. The live state instead is what is actually deployed inside the cluster. As you can imagine, the job of Argo is basically to reconcile these two states. So to make changes to the live state so that it gets as close as possible to the target state. And how does ArgoCD do that? Well, it's basically an endless loop between two different actions. The first action is called refresh, and it's the action in which ArgoCD compares the latest code that is available in Git with the live state of the system. And the second state is called sync, which is the process of making an application move to its target state. And basically, Argo does this all the time. It will try to pull the changes from Git, making sure that the target state corresponds to the live state. And if that's not the case, it will enter into a sync phase, where it tries to make the two states equal, basically. Okay, time to get started. So the first step that you should do is, if you want to follow along, of course, otherwise I'm going to demonstrate all these things also in my terminal. So you are going to need your own Git repository to store a configuration of our infrastructure, right? We cannot work all together on the same repo. So my idea would be that you can head to github.com/Andrea Giardini GitOps workshop and fork it. It's very important that you fork it in your own private GitHub account, for example, because during the workshop, you will use this fork to store the configuration of your application. So you are going basically to always push and commit to that particular fork. No worries, I'm going to paste this link in just a second inside our chat. Here we go. So you don't have to copy paste, and you will have no problem spelling my name right when typing the URL. So the first step would be, as I said, head over to this page and fork this particular repository. I'm going here on GitHub, and I'm going to do it myself. So this is the page. As you can see, github.com/Andrea Giardini GitOps workshop. I'm going to click on a fork, and I'm going to fork it in this particular organization, which is just a private organization that I have. So I'm going to fork it in this private organization. It's taking a couple of seconds, of course. And then I'm going just to clone it in this temporary folder. So git clone. Wait just a second. I'm just going to add my SSH keys. And now I can just clone it. Perfect. Here we go. So I created a local clone of my repository. Okay, so I just cloned the Andrea Giardini/GitOps workshop into a private organization. You can, of course, clone it to your private profile. And I just cloned the repository into my local laptop. Perfect. What's the next step? As we were saying, there are a couple of tools that we need, right? So ArgoCD does not do any kind of, manifest rendering or templating or anything like that. It uses external services to do that, external tools. That's how we called them before. Kustomize is one of these tools. So Kustomize, in case you're not familiar with it, is a CLI that allows you to manage Kubernetes object in a declarative way. It works in a very similar way compared with Git. So you will have like a base Kubernetes manifest, and then you will add basically patches on top of it. Let's have a couple of a look of a quick example. Okay, so let's take just an example to show what is the structure of customized files in general. So let's imagine that we want to have the same application on staging and production with a different amount of replicas. This may because, on production, we're receiving a lot of traffic. We might want 10 different replicas. On our staging environment, maybe just 2 replicas are enough. So these are our use case. We want to deploy an application in Kubernetes in 2 different environments. Well, of course, what I can do is just take the YAML file, copy paste it twice, and change the number of replicas from 2 to 10, right? And just use 2 completely separate YAML file. Or I can use Kustomize and be a little bit more smart about it. Let's put it in this way. Let's have a look at the structure of this repository. So the first step that I will do is create a folder called base. The base folder is my base, directory basically, with a set of Kubernetes resources and a customization.yaml file. So it doesn't really matter the number of replica that I put in here, because this will just be used as a blueprint for my production and staging environment. Okay, so in here I define my deployment or the deployment of my application. I can define my ingresses, I can define my services and so on. But this is not actually what is going to be deployed. This will be used just as a blueprint for my staging and production environment. Where is the code for staging and production environment going to be? Well, it's going to be in two separate folders. So we create a separate folder called overlays. Let me move this. We create a separate folder called overlays, and in there I will create two folders, one of them called production and one of them called staging. And in here, I will actually track the drift between my base and my production environment, or my base and my staging environment. So remember that Kustomize works a little bit like Git, okay? So what this is going to do is take everything that is inside my base folder and then apply a patch on top of it that says, okay, I don't need 1 replicas, I need 2 in case of staging, or 10 in case of production. So remember that the overlays are always applied on top of the bases, like a patch on a Git repository. So in this case, we don't need to copy the whole YAML file 2 different times. We have a single base with the whole definition that we want to use as a blueprint. And inside the production and the staging folder, we just keep track of the differences. So inside my repository file, you can find it yourself inside the repository that you just cloned. You can see a perfect example of that in the file under ArgoCD_deploy/customization.yaml. This is a simple file that is used by Kustomize to compose basically our Kubernetes manifest. Okay, let's get started. So the Argo stack is composed by a multitude of different independent projects. We will see just the basic one, of course. So if you want to follow along and do it on your own laptop, you can just head over to the readme.md file that you have in the repository that you just cloned and follow the instruction in the section 0 setup. I'm going to do the same operation myself. So if you wish, you can just follow along the presentation and you will see everything that you need to do basically. So again, this is my terminal on the left. On the right, you can see the repository that I just cloned. I go down here and I check the setup section. Well, of course, the first step for GitOps is basically we need, first of all, a Kubernetes cluster, right? So I'm using Kind in this case. It's a software that allows you to create a local Kubernetes cluster, and I'm giving it a configuration that is already present inside this repository. So let me just copy paste this command. I click enter, and in a couple of minutes, I should have my cluster up and running. As you can see, right now, Kind is spinning up the cluster, making sure that everything is in place, starting the control plane, and starting all the components that are part of Kubernetes. So in just a couple of seconds, we should have our Kind cluster up and running. Let's have a look. So kubectl get pod dash uppercase A stands for all. So I'm asking Kubernetes to print all the pod. And here we go. The cluster is still booting. We can see that there are still certain pods shown as pending. Now I'm going to wait, give it a couple of minutes more. And here we go. Everything is running. The next step that we need to do is obviously install ArgoCD, right? That's the first step, right? How do we do that? We are going to do that in this way. So we are basically just going to run Kustomize inside the ArgoCD folder, the ArgoCD_deploy folder. This is a simple folder. As you can see, there is a customization.yaml file. There is a overlays folder that we have seen before, and a couple of more things that we will need later. Currently, my customization.yaml file is very simple. As you can see, I'm just specifying a name of the namespace that I want to create. As you can see, nothing particular. I'm specifying a base. In this example, I'm using as a blueprint a remote base, meaning that I can use a local file, but I can also use remote files. In this case, it's hosted directly on GitHub. and I'm just creating a small resource. This resource is just the ArgoCD namespace, okay? So when I run this command, what's going to happen is that Kustomize is going to compile this manifest for me, and by piping the result into kubectl apply-f, I'm basically going to run this command and send the output of Kustomize to my Kubernetes cluster. Remember that in the beginning I said that we don't want to use kubectl apply. Well, this is the only exception that we will have. We will see later how we can even manage ArgoCD let ArgoCD be managed by itself, basically. Let's have a look. So I run this command. This is just a Docker run command running the tool Kustomize version 4.5.3. I'm asking Kustomize to build its manifest, and then I'm piping the output into kubectl apply-f. Okay, let's press enter. We'll have to wait a couple of seconds. Remember that now Kustomize needs to pull certain resources from outside, needs to compile all the manifests. And as we can see here, a whole bunch of resources have been created. We can see there are some network policies, some deployments, some cluster role bindings, service account, and so on. So a bunch of things have been created. Let's have a look again with kubectl get pod-a to show all the pods. Perfect. As we can see up here, let me unzoom a little. Oh, no, that's maybe too much. But as we can see up here, the ArgoCD application is now getting up and running. So it needs to pull a couple of different containers. Right now, it is pulling a couple of different pods and so on. Some of them are in pod initializing state. But here we go. In just a couple of seconds, all the pods are running and ArgoCD is ready to get started. How can we access ArgoCD? Well, that's quite easy. This is, of course, not a production deployment, but you would probably have something more secure in production. But yeah, I mean, if you're running ArgoCD in this way, just with the default parameters, there is basically a secret that you can use to access the web interface. So now I'm going to set to get the secret using kubectl get secret. This will give me the admin password for my own personal ArgoCD. And then I'm going to set up a port forwarding. In this way, I will be able to access the ArgoCD interface. So in here now I have to go to localhost 8000. Oh no, sorry, 8080. Of course, I have to tell them that it's fine if the connection is not encrypted. And here we go. Here we have our ArgoCD interface. By default, you have the possibility of also connecting it with your, LDAP, Active Directory, Okta, whatever that may be. So also authentication comes into place here. By default, I can access with admin password, admin username, and the password that I just copied from the kubectl get secret. So if I click now sign in, I should be able to see the ArgoCD web interface. As you can see, it's a super nice interface. Very, modern, I would say. But we see right now that there are actually no applications that are managed by ArgoCD, right? We just installed it, so that was sort of expected, let's say. But yeah, we will see now how to add applications and how to make sure to let Argo manage these applications for us using GitOps. So at the moment, we installed Argo. It works. We are able to access the online web interface, but of course, there is no application defined inside our ArgoCD instance. So the ArgoCD interface, as I was saying, I just showed it to you, but basically you have the possibility of hooking it up with your login system and of course the possibility of visualizing all the applications that are managed by Argo. So what will be our first tool and our first application? Remember that the tool is the software that we use to compile our manifest, to template our manifest. Well, we just used Kustomize to create our ArgoCD. So I think the best way of testing ArgoCD is by letting ArgoCD manage itself. So our first tool that we will use to render manifest will be Kustomize. This is the tool that we just used to install ArgoCD. And our first application will be ArgoCD itself. So ArgoCD will basically manage itself inside our Kubernetes cluster. Let's see how we can do that. There are a couple of things that we need to do before doing this. So remember that we need, first of all, a tool, and after that, we need to define an application. So then in the next step, we're going to do two things. The first thing is installing Kustomize in our ArgoCD deployment and making sure that it's recognized by ArgoCD. And then we will add our ArgoCD application. As an example, in here, using ArgoCD, I can use ArgoCD to add new keys. I can use, Kustomize to add a new key to an existing config map defined in the base. So, for example, I can define in here an ArgoCD config map and say, well, you can use Kustomize version 3.10.0, and this is the path that you should use. I'm going to show you all these examples live. And then once we have Kustomize installed, we define our application.yaml. Whenever we deal with Kubernetes, you know it better than myself, we always talk in YAML language, basically. So as everything else with ArgoCD, but also as everything else with Kubernetes, also monitored applications are defined as CRDs, okay? So whenever I want Argo to create a new application, to monitor a new application, to monitor a new repository, I need to create a new YAML file of this kind equal to application. So we are going to create a YAML file of this type with kind equal application. The metadata name is ArgoCD in the namespace ArgoCD. And then we need to define a couple of more parameters that allow ArgoCD to understand from where it should get the manifest data to where we want ArgoCD to deploy this manifest data and which criteria ArgoCD should use in order to sync this data between the Git repository and our Kubernetes cluster. For this reason, we have, of course, a specification section. This we have it also with normal Kubernetes resources. And then one very important part of this manifest is the source. Source says basically from where ArgoCD should get the manifest. So where is our Git repository? Where is it located? How can ArgoCD access it? And which tool ArgoCD needs in order to render the application that is hosted in the Git repository. So in this case, you see in here, I'm specifying, of course, a repo URL. This is the Git repo that I want to clone, basically. Target revision. So in here, I can specify, do I want to clone a specific tag? Do I want to clone a specific branch, maybe, and so on. Then we have a field called path. This means if there are a certain number of folders inside this repository, in which folder should I get in before rendering all the templates? And finally, looking here, I'm specifying which tool ArgoCD should use to render those manifests. In this case, I'm asking ArgoCD to use Kustomize version 3.10.0. Well, now we have the source. So we have basically from where our manifests are coming, from where our manifest should be pulled. What's the next thing that should appear here? Well, we definitely need the destination, right? A target. We said that ArgoCD allows you to deploy applications, of course, in the same Kubernetes cluster where it's installed, but it can also deploy applications in Kubernetes clusters that are hosted elsewhere. So this is the destination section. When we talk about destination, we say, where do we want these resources to be deployed? In this case, I'm saying that I want these resources to be deployed in my local Kubernetes cluster, so in the same Kubernetes cluster where ArgoCD is deployed, in the namespace ArgoCD. So just a couple of fields to get basically a destination for our manifest, destination for our resources. And finally, a couple of more settings that are more ArgoCD specific. For example, automated sync policy. So what should happen when the live state does not match the target state, and so on. So in here, what we are saying with these three options, which are, I think, the most common ones, I would say, the prune option basically says if a certain resource is removed from the Git repository, allow ArgoCD to remove it itself. Self-heal means if ArgoCD detects a configuration drift, so the state inside my cluster is not the same as the state inside my Git repository, ArgoCD should take the appropriate step to fix it. And the last one is more of a, safe, like a fail safe. Let's put it in this way. Basically, it's saying if the manifest that you're rendering is empty, do not allow it to be deployed. This is sort of like, like sometimes you introduce a bug, and for example, all of a sudden your template comes empty. You don't want ArgoCD to wipe out all your resources, but in this case, you just wanted to print an error and say, hey, I tried to render your manifest, they have been rendered empty. I'm not going to delete every resource that is inside your cluster. This is a fail-safe mechanism, basically. So let's have a look at that. So we will now try to manage ArgoCD with ArgoCD, and it will have two stages. The first stage is to install Kustomize inside ArgoCD, and the second stage is to let ArgoCD manage itself. So create an ArgoCD application and deploying it in our cluster. So let's start step by step, and let's go through the README file, okay? So as I was saying, you can go through this by yourself, but the idea is that ArgoCD is very unopinionated. So it leaves you the total freedom regarding which tools you want to use to render your manifest. It's not important. As long as they are installed in ArgoCD, ArgoCD will use them. So any kind of external tool that you want to use, Kustomize, Helm, you want to use Play YAML, you want to use a simple search replace mechanism like SED, for example, that's all good for ArgoCD, as long as, of course, they're installed and configured. So the first thing that we're going to do, let me change this shell here. Now I just moved into a different shell because I want to leave the port forwarding active so that we are able here to still refresh the interface and see the changes. So the first thing that I'm going to do is add a couple of patches to my ArgoCD deployment. What will these two patches do? Let me show it to you very quickly. I will show you just one of them for the sake of brevity, but the idea is ArgoCD CM. Yeah, that I'm installing a version of ArgoCD. A version of Kustomize in ArgoCD. So I'm patching a couple of config maps and deployment so that on boot, what will happen is that Kubernetes will download Kustomize from GitHub and make it available for ArgoCD to be used. And this is done using these two patches. So let me go into my Vim, ArgoCD deploy, customization.yaml, and I need to remove this couple of lines to make this happen. So this is just adding a couple of patches to my manifest. One of them is basically saying to ArgoCD that it should download Kustomize from GitHub before booting up. And the other one is just configuring basically Kustomize to be used. So now I can close this, this file. And of course, I can apply it using the same command. Remember that at the moment, ArgoCD is still not managing any application, so I will still have to run Kustomize locally and make sure that it works correctly in this way. From the next step on, we will see that we will not need to do that anymore. So let's verify that ArgoCD has been, you can see right now there is the deployment has been changed. You can see I basically added an init container. And what this init container is doing is pulling Kustomize from GitHub and configuring it inside ArgoCD. So in just 1 second, here we go, it's up and running. Next, what we need to do is to create the so-called application.yaml, right? This is exactly the application.yaml that we have seen in the slides just a second ago. So you see the YAML file, kind equal to application, name ArgoCD, namespace ArgoCD, project default. You see my source section, you see my destination section, and my sync policy. In here, there is something important that I need to replace. In here, I need to specify from where I want my manifest to be pulled. In this case, I'm just going to replace it with the repository that I just forked. This is why I said in the beginning that it was very important for you to fork the repository, not just clone it. So you need to fork it on your own profile. What this is going to do is create a new application in ArgoCD that will pull the source code from this particular repository from the head revision, so basically from master. And then what ArgoCD will do is enter the ArgoCD_deploy folder and render all the manifests using Kustomize version 4.5.3. Where are these manifests going to be deployed? In our own Kubernetes cluster. So the same Kubernetes cluster that we are running inside Kind. Okay, let's see if that works. It's very important at this stage to, of course, commit. So I need to commit all the files because otherwise ArgoCD will create this application that will uninstall itself. So we need to make sure that locally we have the same version that is on GitHub. From this moment on, right after this, I will run Kustomize one last time from my local machine. And after that, I will not need to run Kustomize anymore. Every other deployment is going to happen only through ArgoCD and Git push. So deploy ArgoCD. Okay, file is committed. I do Git push origin master. The file has now been pushed. I run this Kustomize one last time. And this will basically just install this application.yaml file inside my own ArgoCD. What we should see is a clear change in this dashboard. As we refresh, not yet, maybe, or maybe, no, I did something wrong. I didn't enable this in here, right? So in here, I should also enable that particular file before applying. I just changed it. I didn't tell ArgoCD to pick it up. So I also needed to change this. Let me commit and push again. And now if I run Kustomize, this should now work because I've included it in my customization YAML. And here you go. As you can see on the right side, I've now applied my customization.yaml file. This customization.yaml file now includes an application manifest. And here we go. Our ArgoCD is here up and running. And this is the same ArgoCD that you are browsing. So ArgoCD is managing itself. You can see that ArgoCD also gives you a very nice web view. I find this particularly useful with developers to understand how the traffic flows inside the cluster and so on. It gives you an health status of your application, if it's synced correctly, if it has been pulled correctly from Git and so on. So it's super, super, super nice. Do we want to test it out? Do we want to take like an extra time and see if what I'm saying is actually true? So if ArgoCD is managing itself, well, ArgoCD should also be able to upgrade itself. Am I right? So let's give it a try. So keep an eye on this number here. I'm now running ArgoCD version 2.3.1, okay? Now, I'm going into my ArgoCD deploy customization.yaml, and you see in here, I have it ready in case you want to repeat it at home. I'm saying, well, I don't want version 2.3.1 to be installed. I want version 2.3.2. So I'm installing the next patch version. So now you will see that I will not run Kustomize anymore. I just want to run git commit or git push. Okay, so git diff will show you that the only difference in this Git repository is that I replaced the line with version 2.3.1 with the line with version 2.3.2. So when I push this, what should happen is that ArgoCD automatically updates to version 2.3.2. Let's give it a try. Git commit -am upgrade ArgoCD. Perfect. I commit git push origin master. So now the change is going to be pushed to my Git repository. By default, ArgoCD, what it does is that it will pull your Git repository every 3 minutes. This is by default, or every 5, I don't recall correctly. It's possible, obviously, to create, for example, a webhook. So to let GitHub send you a webhook whenever a new push is sent to your GitOps, to your Git repository. For the sake of brevity, of course, we didn't do that, but we can try to trigger it manually. So if here I click on refresh, this is the button for refresh. what ArgoCD will do is pull this repository, render the manifest, and if everything goes well, update itself. Let me do one thing before I click on that button. kubectl get pod -n ArgoCD-w. This lists all the pods that are inside the ArgoCD namespace. And if I did everything right and I click this, what we should see is that ArgoCD will see that the application is now out of sync. And as you can see on the left side, it's now starting to update itself to the next version. So you can see as soon as I clicked, ArgoCD noticed that the manifests that are inside my Git repositories are different than my actual live state. And so it's trying to reconcile the two states. It does this by re-rendering and reapplying all these manifests. So now it will take just a minute, pulling a couple of different images. I think we should be almost done. Let me just verify quickly with kubectl get pod ArgoCD. Perfect, we can see that all of them are running. Remember that here I have version 2.3.1 now. This is the old dashboard that of course didn't upgrade yet. I will have to, before, reset the port forwarding because the pod changed. And if I now refresh from 2.3.1, I now have version 2.3.2. And this is the version I want to upgrade to. So this is the proof that ArgoCD managed to upgrade itself flawlessly. Super, super, super nice feature of ArgoCD, because once we run Kustomize once, everything will be built for us. Let's go into the next section. I see that there are a lot of questions. Let me go through them at the end of the presentation. I just have another little section where we will talk about monitoring and how to deal with Helm charts, and then I will go through all the questions, I promise. Let's talk a little bit about monitoring, and let's see how we can do the same thing using Helm charts, basically. So for our monitoring system, if we want to install something like Prometheus, Grafana, Node Exporter, you might be familiar with certain things like that, we need to create a separate application, of course. It's not the same application as ArgoCD, it's a whole separate application. And what happens if we want to create a different application? How can we create a different application in ArgoCD? Well, yeah, you guessed it. We need a YAML file, of course. So we will create a new application YAML file in the same way as we just did. Okay, so we have our YAML file with kind equal to application. The name is kube-prometheus-stack. The namespace is ArgoCD. And what do I need? As usual, I need a source, a destination, and a sync policy. In this case, you can see that the source is similar, meaning that I use repo URL, target revision. I use a different path in this case. And well, in here, you can clearly see that I'm not using Kustomize anymore, but I'm using Helm. In this case, I did not install Helm separately because by default, ArgoCD includes its own version of Helm just to make our life easier. Of course, I can also just download my own version of Helm and let ArgoCD do all the work. Remember that as soon as a tool is available inside the ArgoCD pod and we configure it correctly, ArgoCD can use any tool out there. It's very unopinionated. Then, destination, this doesn't really change too much from the one before. And final sync policy, even in this case, pretty similar to the one before. In this case, I added a sync option here saying, well, please also create the namespace for me. But yeah, the key part here is that I'm using Helm instead of Kustomize. So I'm using a completely different templating tool. But I want to spend 1 second talking about this section, the source section. Because many questions when I talk about GitOps at conferences, online and so on, are about what is your strategy? What do you do? Do you track a certain branch? Do you track a certain tag? Do you track a certain commit? What do you do? Well, there are different ways of doing it. And my answer, you're not going to like it, is it's up to you. It's up to your need and the need of your company and the maturity of your development team. But let me show you the different possibilities that we have. So whenever ArgoCD tracks a repository, it can track different things. We can track a branch, we can track a Git tag, we can track, for example, a Git commit. Some of these approaches are more flexible and the other are more rigid. Let's go through them and just let me show you which one is more flexible, which one is a bit more rigid. From a point of view of flexibility, well, head tracking is super flexible. This means, for example, every time I push something to the master branch, just pick up what is there, render it, and put it inside my cluster. This is what we have been doing just a second ago with ArgoCD. This is the easiest way of doing GitOps. It's also, in my opinion, maybe fine for like a dev environment or a staging environment, maybe, but it's risky for production environment. Why? Because we don't have a good tracking, right? We cannot say, for example, okay, what was the status of master on, on this date 3 weeks ago? It's very difficult to figure out. Another way of doing tracking is doing it using tags. So you can track a Git tag, and in this way, you with a Git tag, you know that you are basically setting a certain commit in stone, basically. Let's put it this way. So these are a little bit less flexible because, of course, tags are, well, in theory, not movable. Of course, we all know that you can force push, but that's not super good practice. But still, less flexible than tracking a branch, but not as flexible as tracking a certain commit. This is something that you might want to do, for example, in production, especially if you're running, if your company is like very security oriented, you're working for a bank, you really want to be sure that you are deploying a certain commit of a Git repository, not just a tag, definitely not a branch. So these are the 3 approaches that I usually use. Let's put it in this way. So tracking a branch, tracking a tag, or tracking a certain commit. They go from, tracking a branch, the more flexible one, but also the most dangerous one, I would say, to the one tracking a single commit, which is super rigid because every time I want to change the deployment, I need to edit my application.yaml file. But still, in certain use cases, in certain companies, that might be needed. Certain rigidity might be actually needed. Let's have a look at this. So let's have a look at our monitoring stack. So what I want to do right now is deploying a complete monitoring stack made by Prometheus and Grafana mainly. And I want to do that not using Kustomize, but using Helm. So in here, we have our ArgoCD interface. You can see ArgoCD is quite happy. No problem that you see here. Application is healthy, status is synced, sync result is okay. So ArgoCD is pretty happy. Next, what I'm going to do is follow, of course, the monitoring section. There are a couple of things in here that we need to modify, not too many though. So the first thing is that we need to open our application.yaml file and change the URL to our custom repository. You can find this file in ArgoCD app kubeprometheus stack.yaml. Okay, so in here you see that you have application.yaml file, blah, blah, blah. And in here you have a comment saying replace me, right? Because we want ArgoCD to track our own repository. So in this case, I'm going to change this to my own repository. Copy and pasting it in here. Perfect. So now my application.yaml is has been changed, is modified correctly. I don't want to make the same mistake as before. Now I need to go into ArgoCD customization.yaml file, and I need to include this application. So in this way, ArgoCD will include this application inside the stack. This, remember, is just rendering an Helm file. So a Helm chart that I have in the same repository for the sake of practicity, but I could also render an external Helm chart hosted on GitHub, for example. Now, same operation as before, git commit -am, add monitoring. I will push it, git push origin master. Here we go. I go in ArgoCD applications. As usual, I could wait 3-5 minutes to get this, to let ArgoCD notice of these changes by itself. In this case, since we are, time limited, we didn't set up a webhook or anything. I'm just going to press refresh here. So what I should see now is that ArgoCD, first of all, notices that there is a new application, which should be our monitoring stack. Let's see how long it takes. here we go. We see that a new application has been created automatically. I didn't have to do anything if not git commit. Not only, ArgoCD noticed that this application is currently missing, right? We don't have our monitoring stack installed yet. kubectl get pod -a-w, just to show you that it's installing it basically. And as you can see right now, since the application was missing, but it was defined inside our Git repository, ArgoCD is now installing it for me. So you can see on the left side that inside our cluster, there is quite some activity. This might take a minute because it's pulling a lot of different containers. But the idea is that ArgoCD is now getting into rendering the manifest, applying it, making sure that everything works correctly. And if everything goes well, in a couple of seconds, hopefully, our application will be up and running, healthy, with all the pods working correctly. So there's still a couple of different things. Let me see if I can. Sometimes the collection is lost here, so we'll have to refresh my proxy. Here we go. My Kubernetes stack application is up and running, healthy, synced, sync is okay. You can see that a lot of different resources have been published. And now what I can do is, well, I promised you some Grafana dashboard, right? Well, let me show you what we can get with that. Now I'm getting the default secret from Grafana. This is just a prom operator. I'm creating another port forward to Grafana. And let's have a look. If I do localhost 10,000, here we have my Grafana dashboard, admin. These are just the default. Just one sec. Prom operator. Here we go. So this my Grafana dashboard is already hooked up to my monitoring system. And look, on top of that, what I've done is create an ArgoCD dashboard. This ArgoCD dashboard, let me move this on another screen. This ArgoCD dashboard gives me immediately an overview of my GitOps system. It tells me that ArgoCD is up and running since 10 minutes. We just installed. We have a single cluster defined with two applications, ArgoCD itself and our monitoring system. We defined a single repository, which is the repository that we just cloned. And at the moment, there are two applications that are defined inside my ArgoCD. I can see, of course, right now there is not a lot of data, but I can see the health status, the sync activity, controller. I can see some cluster information, and so on. Remember that, of course, as GitOps becomes part of your infrastructure, you will also have to monitor your GitOps agent, in this case, ArgoCD. A couple of closing remark tips, and so on. After that, I promise we will move into the question and answer. We have still a bit of time, no worries. So, nice feature about ArgoCD, things that I personally like about ArgoCD. No external database for state. So we didn't have to install an external database. Everything is managed as Kubernetes resources. We've seen that we've created applications.yaml file. This means that we can also render those resources using Helm, Kustomize, or whatever we might want. So no external database to maintain. You won't have to deal with database migrations or things like that. It's a very, to me at least, clear declarative approach. It follows very much the Kubernetes model. Rendering YAML files is not done, using opinionated tools. We can just specify the tool that we want to use, and Argo will just execute for us, basically. Configuration drift detection, this is super nice. This means that, for example, if one of your developers gets inside the cluster and deletes something, ArgoCD will restore it back to its original state in just a second. Rollbacks becomes much easier depending if you have, depending from your use case, but in general, rollback is equal to git revert. So if I notice that I've deployed a faulty version of my application, I can just git revert that commit, push it, and then ArgoCD will just re-render the manifest and roll back to a previous state. And I also love the ArgoCD web interface. It gives you always a clear overview of the cluster status. It just gives also developers, I would say, a nice way of visualizing what is going on inside the cluster. So you might give your developers read-only access to the ArgoCD dashboard. That's also a possibility, so that they can see what their manifest in their applications, how their applications is running, basically. And it's a very hands-off approach. As you've seen, in the beginning, we had to run a couple of times Kustomize and the kubectl apply from our shell. But as soon as we got things configured and up and running, well, everything else was very hands-off. Git commit, git push, and here we go. A couple of things I don't like about ArgoCD. Best practices. GitOps is, in general, something relatively new still. So you will find many different blog posts online, some of them talking about ArgoCD, some of them talking about Flux, some of them talking just about GitOps in general, sometimes with even conflicting information, meaning that there is not yet a set of best practices that we all share, basically. So it might be a little bit tricky in the beginning to get used to this mentality. It's not a one-fits-all solution, meaning that depending on your company size, how mature is your infrastructure team, and so on, this might not be the right solution for you, or you might not be ready for that yet. Let's put it in this way. And secret management can or might get a little bit more complex, depending on how you're doing secret management. I've seen that there were a couple of questions about that, so I'm going to expand it in the Q&A session right after. A couple of things that I suggest you, if you want to go to this route, if you want to, try to implement GitOps in your infrastructure and, get your feet wet a little bit. So first suggestion is start small and slowly increase the scope. Don't go all in. Remember that ArgoCD in particular, I don't know Flux too much, but I guess it would be basically the same. We can also let one application inside our cluster to be managed by ArgoCD. It's not an all or nothing solution. We can just let a couple of namespaces be managed by ArgoCD. So my suggestion, if you want to start with GitOps, let it be ArgoCD or Flux, start small. Start with like a small scope, a small namespace, a small project, and then slowly increase the scope. Make sure the synchronization doesn't take too long. Right now, you've seen we've just rendered a couple of manifests. There were not too many resources inside. Of course, as you start using GitOps, it might be that your sync process takes a while. And of course, if this time gets too long in the order of minutes, well, this might also get a little bit dangerous and bite you later. Monitor your GitOps pipeline. This is why I like showing this monitoring example. It's important that after you have deployed ArgoCD, Flux, whatever your GitOps solution is, you also keep it monitored and make sure that it's running and it's not having any troubles. Ensure that external dependencies are pinned, but this is valid for any kind of software project, I would say, and make sure that you have a strategy to update them, right? So you don't want, of course, to track external dependencies on their master branch. You always want to tag to at least pin them to a certain tag, but more importantly, always have a strategy to update them. Otherwise, especially in the cloud world, if you are like 2 months behind, it's like being a decade behind, basically. Finally, hope for the best, prepare for the worst. You can see like easily like how such a tool has such a power to create a new application, but it also has a lot of power in terms of like deleting your application. So make sure that, especially in the first, especially in the early time where you're basically getting used to the tool, make sure you have like a big red button that you can press whenever things are going wrong and you don't understand why, right? It's nice to have automation. It's nice to have these tools that help us to do our work, in a faster way, in an easier way, definitely. But make sure, especially at the beginning, that you have a strategy in case things go south and you need to fix things manually. Okay, don't rely 100% on ArgoCD to fix your problem, whatever they are. Thank you very much. Yeah, this is the end. I see that there are a lot of questions in the chat. So I think from now on, we can basically, answer a couple of them. Let me go back to, okay, let me go back to the stage in here. Pascal, I'm not sure, do you want to bring the questions? what works best for you? I'm afraid we don't hear you.
Now it's better?
Yeah, now we do. Now we do.
Okay, apologies. Yeah, that double mute. One on my headset and the other one on
No
Zoom.
problem.
There are a couple of questions, a lot of chatting actually here.
Okay.
One of actually that questions that actually came most up is actually okay, but it's more like okay, when would we use Kustomize, and when, for example, would you wield Helm, for example, for rolling out things and packaging things, for example, using ArgoCD?
So between Kustomize and Helm, this is the question.
Yes.
Like when would be better to use one or the other? Look, in my opinion, is more of a matter of a personal preference, I would say, meaning that there is no absolute tool that is good for every job. Okay, so some people prefer Helm, some people prefer Kustomize. This is what I can tell you in terms of differences. Helm is obviously a much more mature tool. Okay, so it's a tool that has been developed since years. It is a very big community. Very often when you want to install a certain application inside your cluster, there is most probably an Helm chart maintained by the maintainers out there. So Helm is an easy solution. What I don't personally like about Helm is that it gets very verbose very, very fast. So when you have to write all this templating language inside the YAML file, when you have to predict every possible combination of settings that the user might have, this means creating Helm charts that are basically software on their own sometimes. And this is what I personally don't like about Helm, but it's just, again, personal opinion. What I do like about Kustomize instead, I like about Kustomize that it works like Git a little bit. It reminds me of Git very much. It's always, well, this is your base, this is your blueprint, and then you want to deploy to staging. Okay, you take the blueprint and you apply this patch. You want to deploy to production. Well, this is the blueprint, and on top of that, you apply this patch to your manifest. So you can customize basically everything without having to template it inside your YAML file. And this is what I personally like. Nothing prevents you to use the two tools together. So it's also possible to take an Helm chart, render it, and then use Kustomize to edit certain fields. So that's also a possibility. There is no, golden rule in terms of, okay, is Kustomize better than Helm, or should I use Kustomize of Helm? It's more of a matter of personal preference. I hope that by giving you a little bit of an overview of the pro and cons of this solution, it's a little bit clear for you on which one would be best, which one maybe works best for you. My suggestion is always to give it a try, basically.
Yes, you see mostly that for Helm actually, there's already a large base actually of Helm charts that you can customize. Sorry for the word customize. And the other way, for example, if you have to do something new, for example, the quickest way to do that, in my humble opinion, is actually using Kustomize, for example. But if I have to work, for example, with different microservices being deployed by Helm, for example, most times I prefer then to go on the Helm. If I do something new, for example, I'm deciding, okay, what would be best? If it's just something very small, let's use Kustomize, but it'll get you up to speed very quickly. And when we need to do something complex, for example, and make it robust, then actually Helm will come in place. But indeed, the learning curve for Helm is much steeper than it is for Kustomize.
I have the feeling as well. It's like Kustomize is a much younger tool. I'm not sure since how long is around. I would say like a year and a half, 2 years maybe.
2 years, and actually
a little bit longer. But
yes,
I mean, Helm has been around since forever, I have the feeling.
Yes, correctly.
So of course, like the ecosystem is way more mature, like the community is bigger, but Kustomize is getting its traction, I think.
Okay. Someone else have a question also.
There was a question about secret management, if I recall correctly.
That could be.
Yeah, there was a question about secret management, and I'm also mentioned it in the presentation that secret management can get a little bit more complex with GitOps, because you're like, well, let's say that I manage my secrets using the classic Kubernetes kind secret. Well, I cannot commit that directly to to your Git repository, obviously, because they're base 64 encoded, not encrypted. So everyone that can access your repository will basically be able to read all your secrets. And here you have two solutions. I mean, that I tend to recommend. Let's put it this way. The first one is using a tool called Sealed Secrets. It's a small tool, super easy to use, I would say, that basically commits your secrets inside your Git repository, but encrypted. So it's a tool that allows you to encrypt a secret as it's entering your Git repository and decrypt it for you automatically when you're basically cloning or you want to edit your Git repository. This is the simplest solution that I found that works pretty well. Or, as Renato is rightfully saying in the chat, you could use like more advanced thing like HashiCorp Vault or like an external secret manager, especially if you're running in a cloud provider. You have AWS Secret Manager, Google Secret Manager, and so on. That's also a possibility, definitely. But in this case, what you will have to do is that in your manifest, you will have to put basically a reference to the secret that is hosted somewhere else. So yeah, that's also another super valid possibility. When I say that with GitOps, it gets a little bit more complicated. It's not really about complicated. It's about it's a little bit more convoluted, I would say. So you need this extra step. You need to encrypt the secret, decrypt the secret, reference the secret that is hosted somewhere else. So yeah, but both HashiCorp Core, super valid solution. External secret manager as well, very valid solution. If you want to go easy and simple, Sealed Secrets is a project on GitHub that I very much recommend.
Okay, that sounds really fun. Good. Any more questions?
Scrolling quickly as well, the chat.
Yeah, there's a lot of chatting.
But yeah, again, if in case you have any questions, of course, you can ping me in my social channel, andreagiardini.com. You can redo this workshop by yourself. You have the repository, you have the link to the slides, so feel free to redo it and let me know how it went. There is one last section that we didn't do for reasons of time, in case you want to do it by yourself. That is basically about notification. So how do I let ArgoCD not notify an external system? Slack notification, Discord notification, anything that basically can receive a webhook is compatible with ArgoCD. So you name it, like a pager duty, whatever that might be. You can let ArgoCD send notification anywhere. So if you wish, what you can do, like in the next days, go back to the repository, open the last section, this notification section, and for example, you can test the webhook notification. This is quite easy to do. Yeah.
Okay, one question on my side. I'm really enthusiastic about the way you teach. I really like it. Very pleasant to listen to. Very clearly actually clear up the topics and that kind of stuff. Do you have a course of your own explaining ArgoCD, the introduction to ArgoCD, doing some projects with ArgoCD and that kind of stuff?
Good question. So this workshop is sort of being sized down to 1 hour. So I have a longer workshop that I bring to conferences most of the time that is more around like 2.5 hours, let's put it in this way. I don't have a full day workshop yet. But I mean, there is so much stuff about ArgoCD that you can show, show and explain, that I would say it's really no problem if you want to create a workshop.
Great. What we're going to do, Andrea, is a little bit later on after this workshop, I will contact you. Let's see what we can do together to do. I'm really looking forward actually to producing such kind of a course. One way, for example, with ArgoCD, the other one with Flux, just to have people, for example, compare them or even that. But
sure.
Really looks like it's actually to work with you in that one. There's more questions with the issue with Sealed Secrets, handling expire. Okay, the first question that we have then is from Sean, and Sean is asking, okay, with Sealed Secrets, if the secrets actually expire, for example, like an applying public cert, how to handle that one?
That's a good question. So for Sealed Secret, there is, I'm having a look at it. Wait, let me first make sure I understood the question. Handling expiring public cert. Because in general, when you deploy Sealed Secret, you have a Sealed Secret operator that handles these, basically expiring certificates for you. So that's usually not a problem. Public cert used to encrypt secret. This is managed using the sealed secret operator, if I recall correctly. But I might be wrong. I'm not sure if it's like a component that is part of sealed secret, or if it's like an additional component that you install. But yeah, check out the sealed secret operator. That might be the answer to your question.
Okay. Another question we get in from Michael, and he asks, okay, what happens if we do a deploy with ArgoCD, and it appears actually at the time of deploy, there are not enough resources in the cluster. So for example, there are no nodes actually available that have enough of the resources, like enough memory. Will there be an auto rollback? Who will do that?
Yeah, good question. So ideally, like in an ideal world, if you configured your cluster correctly and you deploy an application and there are no enough nodes to serve that application, if you're running in a cloud environment, the idea is that your Kubernetes cluster will basically auto-scale, right? So it will grow, it will create more nodes. These nodes will join the cluster and your application will be then deployed. Of course, if you're running like on-prem or so on, this operation might be not as easy. So what you can define in ArgoCD is a timeout. So basically you can say, well, try to deploy this application for 5 minutes. If in the next 5 minutes, you don't, I mean, all the resources that you have deployed are not in a healthy status, you can specify them what to do. Do you want me to error out? Do you want me to roll back? So you have different options in that case. So you have the possibility of specifying what you want ArgoCD to do. In general, yeah, I mean, if you're running on a cloud environment and you have set up the node pools properly, they will automatically scale up. By default, I believe it will time out. So if you don't specify anything, I'm not sure for how long it will take, but it will time out. And basically, you will see it immediately from the dashboard. It will tell you, well, the cloning from the Git repository went fine. So I was able to get the Git repository. I was able to compile the manifest, but now I try to apply the resources and yeah, something is not working. Maybe a pod is not running, or a volume is not present, or whatever that might be. Okay, so you will see it all in the dashboard.
Thank you. Okay, then Sean is asking another question. So we ask, okay, what would actually be the recommended approach for tracking Git out of the 3 options that you provided during the workshop? Yeah,
good question. Again, my personal opinion, okay? So let's put it this way. So what I generally tend to use is for developer environments. So meaning all kind of temporary environments that our developers want to use, blah, 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 just track the branch. So you just tell them, well, everything that you deploy on this, on a development branch will be automatically deployed to infrastructure, no question asked. Then what you might do is having a staging environment. In that case, you can still track the staging branch, for example, or the master branch. Let's put it in this way. In this way, your developer will basically merge a certain branch into master, and as soon as it's merged to master, it will be deployed to the staging environment. And then, for example, you might have, it depends on how many environments you want to have, but you can have a prod and pre-prod environment on Git tags. So you say, you set a certain tag at a certain point in time, you say, okay, well, this is my pre-prod environment, dated 6th of April, 2022. And you test that pre-prod for a certain amount of time. And when, okay, you're confident that that configuration is the one that you want, and it's the one that you want to deploy to production, you just create another tag on the same date, on the same commit, basically. I tend not to use Git commit tracking too much. I don't know, I find it a little bit too rigid. And very often, I mean, I'm a big fan of naming the releases with like the date of the date of the release, because this gives me like immediately an idea of when a certain thing was released. And instead, if I have just a Git SHA, for example, I need to go back, Git log, find out when that Git commit was created and so on. So it's a lot of extra effort for very little. So in a couple of sentences, I would say developer environments, mainly you can use tracking just the branch, I would say. For prod and pre-prod, I would go with Git tags. So just feature branch and master branch. Yeah, basic master. Yeah. So developer environment and the master branch, I would let them follow just the branches, and then for prod and pre-prod tags, I would say. That's what I like to do. But again, you might want to, if you don't have a pre-prod environment, you might use tags also for the staging environment, for example.
Good, thank you. Anyone else still having a question for Andrea? No, I think that we got through the questions. So from my side, let me thank you very much, Andrea, for your really insightful workshop. I really got some nice things about it. I'm definitely going to set up a ArgoCD setup with GitOps in the next days that are actually to come. We can also receive a nice compliments actually about you and about the presentation. So many thanks for doing that. And I hope that in the near future we'll doing some workshops together. Looks like a lot of fun to me.
Looking forward to it. Thank you very much, Pascal. Thank you very much, Sandro, for the opportunity to speak here, and thank you to all the audience as well for all these nice and interesting questions.
Good. Thank you all. Have a nice day. Stay safe, and kindly let us know on the email address what you did think about the course of the workshop. Many thanks.
Goodbye, everyone.
Goodbye. Have a nice evening.